This question is about the energy and forces taken from the 2024 May exam. And you see in this question an object that is placed over a smooth surface, a frictionless surface, will gain some velocity when you will release it from the rest. So important thing is it is at rest at this point when it was released, and when it will reach the bottom, then it will gain certain amount of velocity, and that we can calculate by applying law of conservation of energy. And when it will enter on this rough surface with that velocity, so it will cover certain distance before stopping, that we can also say a stopping distance written by s in the question. So now what is a link between the energy and this coefficient of friction? Basically, let us segregate this question into two segments. In the first segment, let us apply the conservation of energy. Okay, because we need an equation. In this question, we have a certain unknown values. For example, we don't know about the velocity when it will reach at the bottom. We don't know that. We don't know the coefficient of friction, and we also don't know about the height h. So if I say that this is a position A, and let's say the bottom is a position B, so according to the conservation of energy, if no energy is lost because this surface is frictionless, it means that the total energy at A must be equals to the total energy at B. Now, what are the possible forms of energy that this object may have? So of course, that is the one is a kinetic energy at A and the potential energy at A is equals to the kinetic energy at B plus potential energy at B. So when it was at rest, when we release it, so it means that this is zero. So what is a potential energy? That is mgh is equals to, and when it will reach the ground, that is our reference level, then its potential energy will be zero, because the potential energy has been converted into kinetic energy. So what is the kinetic energy at the bottom? 1 over 2 mv square. So we can cancel this mass and this mass, and hence we have made an equation for the height. So in this question, you have to find out the height of the ramp. So what is the equation? It is v square over g. Okay, so let leave it as it is. Now let's talk about the second part of the motion. That is the rough surface, the motion of the object on the rough surface. So students, you can see that we have made an equation in which this v is unknown. Now to find out this v, that was a velocity at the bottom, but when this block will enter on the second segment of the motion, which is about the rough surface, so you can see at this moment I am saying this is a velocity, so we will treat it as an initial velocity for this part of the motion. And where it is stopping? So it is stopping at this point where it has 0 meter per second. And on this part of motion, it will decelerate. Why it will decelerate? Because a constant force will be exerted on this block. If we quickly see, because this is a horizontal rough surface, so the normal force is equals to the weight of the block, and the only retarding force is the one that is obviously in this direction, and this is a frictional force, a constant frictional force, which will produce a constant acceleration and negative acceleration. So you can apply two methods, any one of them will work very well. The first method is of course the kinematics. Okay, because what is acceleration? Acceleration is equals to frictional force over mass. And what is a frictional force? It's a dynamic friction, so which is equals to mu normal force over mass. And why not I should put the negative sign, because this acceleration is negative, it's a deceleration. So a is equals to negative mu mg over m. So you can cancel out m with m, and acceleration deceleration is negative mu g. I will soon tell you the second method also. Now, once we got this acceleration, now let's apply the kinematics equation in order to find this velocity, and then we can find the height. Okay, so which equation should we? So can we apply this equation? V square is equals to, in fact, let me say V prime, because at this point I'm saying this is a V prime. Okay, so final velocity square is equals to initial velocity square plus 2 times a and the displacement covered. So if I put the values, so 0 square is equals to velocity in the beginning on the rough surface plus 2 into negative mu g into s. So you can take it on the other side, and the v square will become equals to 2 mu gs, and then we can plug the value in equation 1. So height will be equals to 2 mu gs divided by 2g, and finally the height of the ramp is what is that, mu s. So that's why it's option D. And before this, because this question was not very small, it took some time, so that's why I'm just showing you that how can you solve, how can you find out acceleration from the other method, that is the work energy principle. So work is equals to change in kinetic energy, and I'm applying work energy principle for this motion. All right, and here the work is done by a frictional force which is negative. So I'm just showing you all of this. I hope you will understand this method as well. Okay, students, so note it down quickly. This is a second method. I have just shown you the working. So I hope you understand this answer is option D.